Okay, guys, here we go for 2.6. We are talking about special functions. So the first one I want to talk about that's in your vocab is called a step function. It literally looks like a bunch of steps, like you're going up the stairs, and that's because we are graphing intervals. So it might look something like these x values have the same y value from here to here. And this would be x. This would be our function f of x. Notice I'm labeling that as f of x instead of y. It still means the same thing. Um, but this is what a step function is going to look like. And it's an interval. It has intervals of answers. And we'll do an example here in a second. The next equation that we are going to look at, you guys already know, but you might not know it as this name. It's called a constant function. And that's because it's constant and the value for y does not change. So it could look like a horizontal line, like y equals 2. Okay, it's going to be some number. Okay. Then we have the identity function, which again, you guys have seen it graphed. I'm going to put it over here on the side. But you might not know it as the identity function. Remember, identity means that they are the same. So x is going to be the same value as y. So if x is 2, y is 2. Also known as y equals x. So it is a slanted line with a positive slope, and it goes through the origin. Okay. The last special function that we're going to talk about is absolute value. So absolute value, we've solved these. We haven't graphed them, but the way they graph, they look like a V. And that should be no surprise because there's no way we can get a negative number out. So if I put like an absolute value of 1, it gives me 1. If I put the absolute value of a negative 1, it gives me a positive 1. So there's no way that is going to come down there unless you have, say, a negative somewhere outside the absolute value to change it. But usually this is what that will look like. It's a V. It's very straight. It's not curved like a parabola. So it'll be straight lines down and up. Okay. So let's go ahead and do the very first example. So we're talking about psychology. So say one psychologist charges for counseling sessions at the rate of $85 per hour or any fraction thereof. Draw a graph that represents this situation. So first let's understand what's happening. You go in and you see the psychologist and you see them for 30 minutes. Well, 30 minutes is going to rate out at an hour because they're doing it or a fraction thereof. So whether you see the psychologist for 5 minutes, 10 minutes, 30 minutes, or an hour, it's going to cost you $85 because that's what they told us right here, $85 per hour or any fraction thereof. So I'm going to look over here at my table and let's call this X. So if I go to the psychologist for 0 to 1 hour, so anything over 0 minutes, not including 0, because if you don't talk to them, they're not going to charge you, and up to 1, they're going to charge you $85, and that's going to be the cost dependent on how long you talk to the psychologist, X. Okay? So let's say you go and you talk to the psychologist for an hour and 15 minutes. It's now going to be 2 hours. Or if you talk to them for an hour and 30 minutes, they're going to charge you for 2 hours. If you talk to them for 2 hours, they're going to charge you for 2 hours. So now we're talking about the time from 1 to 2 hours, not including 1, because if it's 1 hour, they're going to charge you the 85. But anything from 1 and over up to 2 is going to charge you 85 plus 85 because now it's 2 hours and that's going to be $170. Okay, so now you go over 2 hours and you're into 2 hours and 15 minutes, 2 hours and 22 minutes, all the way up to 3 hours, not including 2 but including 3. It's going to cost you $255. Again, I'm adding 85. Does everybody see what's happening here? Okay, so if I continue this pattern, I get these numbers. Okay, so if I go talk to the guy in between 4 and up to 5 hours, it's going to cost me $425. Okay, so the table should make sense, hopefully, now that we've written it out. So let's see, what does the graph look like? So the graph is X, and then the cost, depending on how many hours I talk to the psychologist. Okay, let's label our X values. Our X values were the amount of time that we were with the psychologist. So it looks to me like 0 to 5 would be reasonable. So 0 to 5. I'm going to go 1 over just so I have an extension there. And cost, it looks like cost was anywhere from 85 to 425. So I'm going to do this little zigzag here, which tells me that that is not to the same scale as everything else. And then I'm going to count by, well, I guess I don't need to do that. We can count by 85s. So take the little squiggle off, sorry. We can count by 85s and it'll work. So 85 plus another 85 plus another 85 plus another 85 plus another 85. Okay, so now the question is, how do we graph this? Well, at 0, it costs 85, right? And it's not including 0, so that's going to be open. That was a terrible dot, sorry. And up to 1, it's going to cost 85. So from 0 to 1, it's going to cost $85. As soon as I go up from 1 to 2, it's going to cost 170, but not including 1. So at 1, not including 1, it's going to cost 170. And at 2, it's still, and any fraction thereof. So this is where I get my step function. So again, if I look at 2, from 2 to 3, I'm at 255. So 255, but not including 255. I'm sorry, not including 2. Between 2 and 3, I'm at 255. And then I would have 340 would be from 3 to 4. And I would have 425 from 4 to 5. That's a step function. That's it. Okay? So let's look at the next one. The next one is a constant function. You guys know how to do this. You've done this forever. It's so easy that you tend to make it harder than it really needs to be. So let's start with a table. Let's choose some X values. And you can choose whatever you want. I always try to stay nice and easy so I don't have to worry about it. And then let's plug them in. Well, my function is that g of x equals -3. So everywhere I see an x in my function, I'm going to plug in this x over here. So if x is 0, g of x is -3. Notice there isn't an x in the actual function. Okay, remember that's just notation. It's not for plugging in. Okay, so it looks like everywhere I plug that in, it's still going to be a -3. So when I graph my graph, here's my x, my y-axis, and remember we need to tell Magruder what we're counting by. If I go to my axes and I put those dots in, 0, -3, 1, -3, 2, -3, 3, -3, 4, -3, it gives me that horizontal line that we talked about. Okay. Next we have our absolute value function. Let's see if I can make this any bigger. Nope. It's all good. So next we have absolute value functions. Okay, and I want to graph both of these to show you guys how they change. So the very first one that I want to graph is this f of x, x minus 3. So let's go ahead and choose our x values. So let's just stay consistent and pick what we chose before. We're going to go ahead and plug into our function. So if I have 0 minus 3, I get the absolute value of a -3, which is 3. So that gives me the ordered pair 0, 3. If I do 1 minus 3, I get -2, and the absolute value of -2 is 2. So that gives me the ordered pair 1, 2. And if I keep doing this process, I should get 1, 0, and 1. So ordered pair 2, 1, ordered pair 3, 0, ordered pair 4, 1. Okay, so if I come over to my graph, and I label it, I'm labeling it by ones if you didn't notice. Now I just have to graph my ordered pairs. So the first ordered pair was 0, 3. My second ordered pair was 1, 2. Then I have 2, 1, 3, 0, and 4, 1. With an absolute value, Magruder told you it goes in a V. So right there is where that heads up. Okay. If we do the next one, this g of x is x plus 2, and I make a table. Should have given you guys another table, sorry. And I plug into that, I should get the values 0. Wait a second, I'm lying to you. I chose different values. Oh, that's right. I wanted to show you guys. If I choose different values, you can see the graph better. So I actually chose -2, -1, 0, 1, and 2. Okay, and if you do that, you should get 0, 1, 2, 3, and 4, which gives you ordered pairs -2, 0, -1, 1, 0, 2, 1, 3, 2, 4. Okay, and all I did was plug those in. So -2 plus 2 is 0. Absolute value of 0 is 0. -1 plus 2 is 1. Absolute value of 1 is 1. So that's where I got those. Now I'm going to graph those ordered pairs on my graph. So I have -2, 0. I have -1, 1. I have 0, 2. I have 1, 3. And I have 2, 4. And I went ahead and finished this for you guys. I added an extra dot on there so you could see. And the question is, determine similarities and differences of the graph. Does anybody notice when I graphed the absolute value of x minus 3, look at where the 0 was. And when I graphed x plus 2, look at where that 0 or that vertex is. So there's one trick to help you guys with absolute values. Again, these should be V's. They should not be curved like that. Those are parabolas. Don't do that. Okay, so straight lines. Okay, last example is a piecewise. Okay, and I realize piecewises we might have to come back to, but let's go ahead and try this. So a piecewise is literally what it sounds like. It's us piecing together multiple graphs. Okay, so the very first thing I want you to look at is this x minus 1 right here. So step 1 is you're going to think of x minus 1 as y equals x minus 1. You know how to graph that. Okay, so I highly recommend that you graph this in pencil to start. That will hopefully help with what we're about to do. So if I just asked you to graph this y equals x minus 1, you would put a dot at -1. Magruder needs to order her, or number her axes. Oops. -1, -2, -3. Okay. So I put a dot at -1. And then the slope is, remember, 1 over 1, which tells me from this dot I'm going to go up 1 over 1. And I could keep doing that so that I have that graph. And then we would draw our line through here. The kicker is we only want the part that is x less than 3. So at x equal to 3, that is like an imaginary line right here on my graph. And x less than is to the left on my number line. So I only want this graph to the left of that line. So I am only going to extend it to the left. The other key is that this is an equal to. It has the bar. So you need to make sure on that dot you have a closed circle. Okay, so step 1, we graphed it like we normally do. Step 2, look at the x inequality. Only keep what that inequality tells you to keep. And I wrote this way better on the notes that I scanned in for you guys, so double check those. My steps are probably a little bit clearer, but look at the x inequality. Only keep what that says the graph should have. Okay, in this case, it says that we should only have the part that is less than or equal to 3. So that is why I kept this side of the graph. Okay, and then you're going to start over. Okay, the next graph that it has is -1. So we're going to think of -1 as y equals -1, which means I go to y equals -1 and I put a dot, right? And that is going to be a horizontal line across. Then I need to look at the inequality. The inequality says the only part of that line that I want is to the right, because greater than 3. And it's not equal to. So it wants me to have an open circle right here and only that part of the graph. So notice what I did. I pieced together two different graphs. That's why it's called a piecewise function. Okay, like I said, my steps for the piecewise are way better written out on the handout that I wrote on and scanned in for you guys. So make sure you refer back to that so you can get complete notes. Go ahead and start your homework, and we will obviously go over this in class when we return. But you will turn your homework into Google Classroom. And if you use your time wisely, you should have enough time to finish most of, if not all, of your homework before break. So thanks, guys. And if I can, I always forget how to turn this thing off. But if I can remember how to turn it off,